Hey, hello, and welcome to the show. It's me, John Park. It's time for another episode of John Park's Workshop. So you're in the right place if that's what you thought you were coming here for. Looks like we have good stream health over on YouTube at the moment. Crossing fingers, things have gotten wacky there lately, but we'll see. And I'm also broadcasting over to Twitch and Facebook and LinkedIn and a few other places. So welcome to people over in the YouTube chat. Hey, Dave Odessa and Anthony Becerra. Nice to see you all. And to our viewers that are over on Twitch or other places, Facebook, for example, and you're wondering where the chat is at, you can head over to the Adafruit Discord if you're on a computer. It doesn't usually work for mobile device to watch it and chat, but if you want to give it a try, head over to adafruit.it/discord. Head to the live broadcast chat channel. That's it right there. That's it right there, live broadcast chat channel. My image is mirrored, so it's always confusing to point at stuff on screen. And that's where the chat is happening. So let's see, what else do we have going on? I want to mention a cool position over on our jobs board. So if you head over to jobs.adafruit.com, we have open positions that people have posted, including this one, which I believe Phil mentioned last night. This is someone looking to hire a freelancer to do a prototype of a PlayStation 4 to PS5 custom controller mod. Purpose of this project is to build a PS5 controller from the shell of a PS4 controller, which is a Thrustmaster T-Flight HOTAS 4, using the PS5 DualSense wireless as the innards. So that's interesting, and if you check out the link here, they have a PDF that you can check out with some of the goals for how that's going to work. So it's a typical flight controller with joystick and thrust and some other stuff, and they want to turn that into a PS5 controller. So interesting project. If you're into modding stuff, that could be a neat one to look at. So go check that out over on jobs.adafruit.com. The other thing I'll mention right here, right off the bat, is I've got a show on Tuesday afternoons, which is called JP's Product Pick of the Week. And this was the product pick this past week. It's that Metro M4 Express you see right there. And what I'd like to do is a little 1-minute recap of the show. If you're not familiar with the show, go check it out any Tuesday, except for next Tuesday. This coming Tuesday I'll be out, but then picking it up again on the 19th. On the show, we usually 15-20 minutes take a look at a product pick, sometimes something new, something from our archive, but something you can get at a great discount. This one was 50% off this week. No coupon required. It is a discount that is applied right then and there. You'll see the price represented right as you're clicking on it to send it over to your cart. And this was a little recap of this week's product pick. Wait, that's not it. That's just a Metro card. There we go. It is the Metro M4 Express. One of my favorite development boards. What we're talking about here is a really fast chip, lots of memory. So it's based on that Cortex M4, the ATSAMD 51 chip. And it has a lot of great peripherals on it. Cases where I really love to reach for the M4. I'm at the start of a project. I'm maybe not even sure what board I'm going to use ultimately, maybe not even sure what the form factor is, but I just need to work out some of how things are going to be wired. So I'll go with one of these Metro M4s, and then in this case, this was when I started working on that Pip-Boy project. I wanted to plug in the SPI wiring and get this up and running on a board that I can plug things into. I know it's going to have enough power to do pretty much anything in CircuitPython or in Arduino. The product pick this week is the Metro M4 Express. It was. Let's see. Next up, let's take a look at this week's CircuitPython parsec. I've been doing some display stuff. This one is display related, but it's actually a little tweak on that formula. So here we go. For the CircuitPython Parsec today, I wanted to show you how to use a touchscreen in CircuitPython. This will work with a lot of different displays we have that have touch screens, as well as the bare touchscreen driver and element. In this case, I'm using a PyPortal Titano, the big one. So you can see here, what I have to start with is this really cool bouncing logo. As you may know, I'm a huge fan of the TV show Severance, and I was talking with Todd Bott about this. He has a bouncing ball code he likes to use, and he made a little Lumen logo to use for our screensaver here. But I am not currently severed. I'm aware of all versions of myself. So what I'm going to do is take this basic formula and add to it the ability to use it to change the position of that logo using the touchscreen element. So touchscreen element here can give us X and Y position as well as pressure. I'm just using X and Y. And let's show you first how it works. So all I need to do is touch somewhere on the screen, and you can see I'm repositioning where that logo is. I'm not changing anything about its sort of inertia and angle that it's going at. But if I have it, let's say, bouncing down into the left, and I just want to speed things along and get closer to the bottom there, I can tap it. Just moves the logo to that new position. And in fact, if I click and drag, you can see it'll follow my finger around until I let go. So the way I'm doing this in code, first of all, I'm importing the Adafruit touchscreen library, and then I do some display stuff, set up some palettes, and set up my logo as a bitmap. But the touchscreen stuff is right here. I'm creating this object, I call it TS for touchscreen. TS equals Adafruit touchscreen, and then we're telling it 4 pins that it uses, a 4-wire touchscreen. And on this particular board, they're named touch YD, so y-axis up and down, YU, and X right, X left. So those 4 pins are selected. The calibration values actually are set at the factory, so you generally don't have to mess with those. And then I'm telling it what size the display is. That's all you have to do for setup. Then to use it, all we do is query this, touch equals ts.touchPoint. And what that's going to give us is an X and a Y position on the screen. It also gives us that Z depth. I'm just not showing that here. And then I'm using those to adjust that value that was already in the code for moving this around. So you can use this for things like painting or placing objects or drawing, maybe even changing vertices on vector IO stuff would be kind of a cool use for it. But it is really straightforward to use these touchscreens using that library. And so that is how you can use a touchscreen inside of CircuitPython. And that is your CircuitPython Parsec. By the way, there was a question, someone was confused in the chat about the discount. So the discount on this was when I was playing the 1-minute clip from the JP's Product Pick of the Week show. The discount is only good during the live stream, and that's on Tuesdays at 1 o'clock Pacific, 4 o'clock Eastern time. So sorry for any confusion there, but the discounts on those are just when the live stream happens. So if you can tune into the live stream, or at least figure out what the product is based on tweets and blog posts, you can run over, throw it in your cart, and that discount is applied during the live stream only. So sorry for the confusion there, Hams Labs. All right, so let's see what else is going on. By the way, I wanted to say I did this, as I mentioned before, I did this on the Titano PyPortal, but this would work on, I have that little TFT feather wing I've been showing with a feather for a few of these projects, and any of our other touchscreen projects. I'm excited to actually try out the new StemmaQT-ified version of our touchscreen driver board. If you take a look, let me bring up this touchscreen breakout. Where's the new one? This one right here. So this is this new TSC 2007 I2C resistive touchscreen controller with StemmaQT. So you can see we sell these, I think they're out of stock right now, but we sell these bare elements so you can do projects that are more like a trackpad type of thing, or maybe you want to hide that under the page of a book for an effect. You don't have to have a display. It's actually the touchscreen element can be read using this little driver board, and now we have this I2C version. So you can see in the demo there, it's reading out X and Y on that OLED there on the Feather or TFT. So let's see what is next. Change some screens here. Oh, that's interesting. Dexter mentions in the chat that C. Grover made a tool to calibrate the touch screen. I've got to check that out. Let me bring the Discord up since people are chatting over there. Yeah, I looked into it, and previously we had a Windows-based application for calibrating some of our touch screens, so that's a drag. But I'd love to check that out. C. Grover, I didn't know you did that. Very cool. Maybe you can put a link in the chat to that for touchscreen calibration. These, by the way, if you're not familiar with resistive touch screens, let me go to a large view of that. These are not capacitive touch, so you don't have to use your finger for that. You can use any object. Here I've got a big novelty keychain, so you can see this works more like your old Palm Pilot did. It's a lower resolution, simpler and cheaper thing than capacitive touch. Also, Todd asks, is that the one that Liz used recently? Yes, so Liz Clark just made a really cool project that is let me head over to Learn. I'll bring up if you go to learn.adafruit.com and head to the new guides, view all, you'll see this wireless ESP32 S2 touchscreen controller for pure data. So I guess it's a touch controller, not a touch screen, right? It's not a screen. We always call it that. But yeah, it's a trackpad basically. She's made a really cool sort of wrist-mounted brass knuckles trackpad, and this one uses that same controller I just showed there. You can see it on the side there. So that this can send X and Y values over to I believe she's using a Wi-Fi Midi for pure data, so you can change values in your software using that. Excellent questions. And, oh good, thanks. Looks like C. Grover is going to post a link in the repo for his calibrator. Very cool. All right, so what we got next? After a sip of iced coffee, because it's like 95 degrees here today. Update on the LCARS panel project. I'll actually jump over here and show some stuff. I am taking another pass at using an LED matrix for it, except I've decided I'm going to use a pair of our 2.5 millimeter pitch 64 by 64 panels. I want to get denser so that I don't get fuzzy edges on the LCARS panel. If you're wondering what I'm talking about, it's this Star Trek display, which is backlit, which is why you can't see it very well right here. I have my little light blockers, and I have in there a couple of pieces of polarizing film. And one of the reasons that I did that is I wanted to take a look at the method that was actually used on the show. I mentioned this last night on the show and tell, and in fact, let me look and see if I can find from the chat. There was a really great GIF animation that Yanisku7 posted of one of these LCARS panels on the show, and I just want to show that on here. So let me head to the Discord and look for that. Here it is. So you can see there that sort of pulsing. This is a sort of a ping-ponged clip. It loops forward and backward, but so you'll see things changing direction. But essentially, that panel that you're seeing there is the same as this. It's a vinyl print backlit with polarizing film in different orientations on the backside of that image. And then there's essentially a light box with a spinning motor, and it has a piece of polarizing film rotating. And as that rotates, it causes different angle blocking of the different pieces of that polarizing film. that's a really nice example of, you see what looks like some pretty sophisticated animation. It doesn't look like a screen like we're used to. And in a lot of cases, I think in this one, this was done practically on set using polarizing film. Let me jump over to my workbench here, and I'll show you some tests I did using some different polarizing solutions. So let me, let's see, there we go. Sorry, I gotta fix a screen that got super big and out of focus. Let's zoom that in. Rip. And I have to focus without me being there, but I just have to focus on a little wire on my workbench. There we go, that should work. So let me make that just a little smaller too. Oh, sorry, I had it resized wrong. So I guessed wrong on what the center of that frame is. Let me rotate that camera a little. There we go. Hi, Lars. Okay. Thanks for putting up with that. So here's a couple things to show with polarization. So I forgot to bring some sunglasses, but one thing you can do with most sunglasses, at least somewhat decent quality sunglasses, they'll be polarized so that they block light that's traveling at some wavelengths or some angles rather. If you look at some polarizing film, this is just a sheet of polarizing film. This is also a diffusion film. I have a clearer piece here. This one has some adhesive on it. So here's a piece of polarizing film. You can see it definitely does a little bit of light blocking no matter what. But the more pronounced light blocking you can see is when we get certain angles to match up or not match up. So if you trim a little piece off of this, these were the same orientation, same piece, and then as I rotate that, we get some light blocking. And in fact, if I turn on this light source here, you can see pretty much no light being blocked, and then as I rotate this, we're going to get a whole bunch of light blocking. There's also some dust on there and things. But this is a pretty effective light blocker at some angles. Here's that bigger piece. So you can see there, yeah, there's a lot of junk on this one because it got peeled off. And so that's the effect that's happening, is there's a rotating disc that's causing that LCARS panel to receive light in some of its slots or not. And if you hold up, I'm holding up two pieces right here, you'll see that sort of stacking effect, which is how that animation allows it to sort of travel through multiple sections of the interface. I don't know if they also use a circular polarizer. You can introduce a third polarization angle, and so there are neat tricks you can do if you use a third polarization and circular polarizers. The other thing I wanted to show is another way I've been looking at this is if I take one of our little 3-volt backlight LEDs. So this is, it's going off. This is a little backlight LED. So these are often used behind an LCD panel or other, maybe a gauge or something like that. Again, if you take polarizer, you can really block the heck out of that light in some places. So there's a lot of neat effects you can do to break that up into sections. Of course, you can also PWM or on-off these things behind sections. And another interesting thing I noticed is that we have these sort of welding glasses LCD light blockers. If you give these a couple volts, I think maybe 3 to 5 will work, it will turn this very opaque. Block light's how welding glasses work. But it too is polarized. So If you have one or two of these things, or if you have some film in one of these things, you also have some options for both changing polarizations and turn these things on and off. I'm going to steal my light there for a second and see if I can block that. Let me see if I can. Okay, so I'm going to try to. Boop. So that's the light blocking of giving it current. I can't remember how to get this one to reverse itself. You might have to just reverse the current on that. So those are all some options in that realm of blocking light from a bright source, which is really interesting and obviously a very effective way to do it. It requires some space usually for a motor mechanism if you're rotating it like they did on the show. I showed this last night, but I'll show it again here. This is, you can see here, and there's a lot of light leaking in from all over the place. So this works better if we have light blockers built around here. But if you look at where I'm pointing, there is an element there that has a piece of polarization filter, and then this one up here has a piece of polarization filter, and they are perpendicular to each other. So as I rotate my light, which has its filter on it, you'll see the top one go dark and the bottom one go bright, kind of ignoring the stuff that's going on around. But you can see like these numbers at the top, they're staying lit no matter because there's no polarizer there. Or to do it a different way, we can put this film here or here and it'll block the light or let the light through. So that is where I'm at just with some experiments with this. I'm going to talk to the guy who gave me the panel and see what method he'd ultimately like to go with, but I am going to show a better matrix solution. And also there was a suggestion that Lady Ada had, which is using the matrix panel, since with 128 by 128 pixels, I'll be able to get fairly precise, and I also have this little light blocker in the back. I may be able to not only animate things in blocks, but also pick up their colors, use a matching color, which will also help. So this just requires white light coming through, but there's a chance that if I also do some color matching, I'll get an interesting effect and use less current than pure white, because pure white on those matrix panels uses RGB, so you've got like 60 milliamps per LED, and I got a heck of a lot of them with 64 by 64. So those are all some considerations. I'm going to be using an external power supply for it. I think a 10 amp 5 volt, and see how that works out. And that'll be with the Matrix portal. You can also do this with Raspberry Pi, and we have a driver board for that, which I'm hoping not to use, but maybe gives you some different options for things like playing a video instead of a sprite sheet. So all stuff to come on the LCARS project. So I was not able to check Discord during that or YouTube chat, so let me know if people have thoughts and comments in the chats. I'll bring those up now. Mike Cotterman over on YouTube says, I love those light valves. My daughter made a cool invention from those. Oh, really cool. That's cool. Oh, you short the connectors to turn it. That's right. Thank you. I forgot that's how you get those off. And they can change instantly. If you ever used a automated light blocking welding goggles, as soon as they see a bright light, they flip. Let's see. Let's get down to today's chat here. Oh, jump to the present. All right, Discord. Oh, new gifts from Yanisku. Always worth seeing. He's got stop motion animation of a camera there. That's cute. Let's see. Oh, yeah, you can also, someone mentioned you can change colors. Andy Calloway posted an Instructable on changing the colors of the polarized effect by using packing tape. I believe if you stretch a polarizer, you can make it send through some light waves, wavelengths instead of others. And yes, Seagrover posted the calibrator, touchscreen calibrator. Excellent. Yeah, I knew you had done this. I completely forgot, but now that image jars my memory. Very cool. Let's see, what else? Okay, so moving on then, thanks for listening in on my progress with the LCARS project. Next up, what I wanted to do is it's more of a show and tell than anything, but also kind of an inspirational project, and I have some ideas of some interesting places to take it. So, those of you who are interested in some of the synthesizer and Midi types of things that I also am interested in may be familiar with this project, but it's a really neat one. If you haven't heard of it before, it is called the 16n Faderbank, and it's an open source project. Let me bring up a web page here, and let me put me over to the side. What's a good way to do that? I'll just put that in the background there. That's not it. All right, that way will work. Let me unplug my Lumen screensaver here. So 16n, a bank of 16 faders. You can see here. This is an open source project. You can buy PCBs, you can buy kits, you can buy assembled ones, you can make your own PCBs of them. I have one because I bought a broken one and fixed it. It uses a Teensy 3.2 is what it's designed for, and it uses 16 large, I believe 40 millimeter faders, 10K linear faders. And then the circuit that you build on the circuit board does a few interesting things for you. It mentions here it sends MIDI data out over USB, so that's right over the Teensy. Let me grab mine here so I can show you. I don't have any fader caps on mine, so it's just bare. You'll see it's just bare potentiometer, slide potentiometers there on the top. Move this out of the way here. And you can get different cases for it. I just laser cut sort of a sandwiched case type of thing here. And the USB, there's a little teensy you can see there. So USB MIDI is possible over it. Of course, you could adjust the code. It's in Arduino. You could adjust the code and send out USB HID if you wanted to, or other types of serial USB data. It also does a regular MIDI over 3.5 TRS cable. I can't remember if it's the one on the side or the one on the bottom. Yeah, it's the one on the side here. So there's a TRS cable, and I think this one has a switch for Type A and Type B MIDI, which is nice. And it also, interestingly, has a third jack here, which is for sending out I2C. And then pretty much everything else about the code is configurable. There's an online configurator. You can use like a little web page, web server thing to say what range you want to send out from these and what MIDI numbers, as well as, if you look on the back here, every single one of them can send out control voltage. So this is really useful for older style synthesizers and modular synths, or kind of anything else you have that you would want a low current, I believe, 0 to 5 volts coming out of. So it does a lot, but it also doesn't do anything until you put something on the other end of it, or pick out some software you want to use with it. So that's the basics of the project. It was sort of birthed on the Lines forum. Look up Lines forum and Monome, and you'll find people talking about it there. This is the GitHub for it, and on here there's the BOM and the schematics and board and Gerbers and everything for making the board, as well as the panel if you want to laser cut that, and the software. Flashing it is straightforward. It uses the Teensy Arduino. And what I wanted to do is, first of all, just give you a little demo of it, and then discuss this I2C thing, because I think it's an interesting idea to see if this could be turned into essentially a STEMMA QT quick type of I2C enabled device to give you 16 faders that you could plug right into a Feather or a QT Py or something like that. Could be a really cool lighting controller. There's a lot you can do, even if you didn't want to have a computer involved, just by the fact that it has I2C. Same with MIDI, the fact that it has a serial UART MIDI means that you could read that into most microcontrollers in CircuitPython or in Arduino, which is really interesting. So I'll give you a quick demo over here. Let me jump back to the workbench, and I'll give you a little tour of how this works and set that up and do a little bit of an audio demo. So I'm going to move these light filters out of here. And like I said, you could plug this into a lot of different types of synthesizers. You can use synths that recognize USB host. You could use this with USB, or rather with UART, sort of traditional serial MIDI. Let me put this off to the side. And let me brighten up this monitor here too. Whoops. Okay. And let me see if you can, I can probably do what I want to do with it arranged like this. So there's a funny way to use a laptop. So I'm going to plug this in over the USB. Where'd you go? There you are. By the way, if you like to fix stuff, be on the lookout for broken versions of this, because it has a little micro USB controller on a teensy there, and 9 out of 10 times when someone has a broken one, it's because this has been, whoops, ripped unceremoniously off by accident due to the USB cable and something dropping or getting yanked. So if you're comfortable transplanting a USB connector or a teensy, you can sometimes get these broken ones and fix them, which is what I did. And I actually have a couple others coming to fix for a guy who was asking about that. So what you can see here, in fact, without me doing any noisy stuff, if you look in the right side of my interface there, you can see I'm moving 8 of these faders, the faders on the right, and that is adjusting the note values of these little modules. So what I'm running here is Vcv Rack, which is an open source modular synthesizer simulator, and it has a module over here on the left. Where's this cursor? Is this running? Oh, my mouse is upside down. So there's a module here called Midi CC. Yeah, this is a pain in the neck to use this way. I kind of wanted to zoom. I'll make the view be a little bit angled for a second while I cruise around here. I don't have a mouse wheel on this mouse, unfortunately, so let's see. How do you use this to zoom? Whoa, now I've done it. Hold on one second, let me hold this normal. Not you, yeah, there we go. Okay. So yeah, sorry about the uncomfortable angles. So this, focus a little better. Okay, so this module here is just a USB MIDI to CC thing. So this is bringing in the channels of this fader here. And what I can do is say on one of these slots what MIDI CC value I want coming in, and then just wiggle one of the controllers. This is a pretty typical way to teach MIDI channel information to a piece of software or even hardware, is just to choose one, put it kind of into a learn mode, and then wiggle something and says, okay, I get it. Anything that changes on MIDI CC95 is going to be used there. What it's then going to do is take the values that are sent from this, which are 0 to 127, and convert those into, I believe, by default, 0 to 10 volts in here, or 0 to 8 volts, something like that. And then you can use other modules to change that, clamp that, invert that, do all sorts of fun things. But what you'll see on, let me turn the volume off on this. You can see it on these first ones. So as I change this fader, it's translating the 0 to 127 to essentially a 0 to 1 on a knob for letting sound through, or 0 to 10 volts, or however you want to express that. And so all of these are connected here and live for changing values on this. Let me see if I can zoom, oh, not that. Zoom over here. That'll work. Okay, that's a good view of that. Sorry, that was the view of the back of my head. Let me push this up a bit. Let's see this here. So what I've set this up to be is I have 8 different oscillators that are making a sine wave sound. And so I can change the mix, or the volume essentially of that, with my first fader, and then with fader number 9 here, so it's my second set of 8, I'm changing the pitch, and I've decided to put this through a quantizer so it locks it into a chromatic scale. So what I'll do is actually put all of my pitch faders up to roughly that area, and then I can start bringing those in. Turn this volume up. So you can play it essentially as a drone. You can also go in and change the pitches. And you can see here these ones on the right are flipping through octaves as they go. So if we start one at the very bottom, it's going to go through 12 notes, and then second octave, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So that's the 10 volts. Oh, the computer display just turned off. So very high pitch you might be able to hear. And that needs more volume to hear. It's pretty low bass stuff there, sub-audible at some point. So you can, of course, go in and do kind of anything you want that you want controllers for, either in Vcv Rack here or other software. It's fantastic for things like mixers, right? And that's how I'm using these first 8 here as mixers. But if you're doing any kind of stuff in a digital audio workstation, a DAW, and you want to be able to change faders, you can, of course, get software that'll convert Midi into other things. So you could use this in your video editing software. You could use this in your lighting package, like Lightroom has a good Midi to Lightroom plugin. I've shown that before. But the real versatility of this is, well, you can go and buy commercial things that do that. There's a nice little 8 fader Korg thing for like maybe $100 or less. Nice thing with this is you can customize it to your heart content with code in Arduino. You can also send out different types of outputs, so control voltage right out of the back here. And in fact, let's just take a look at that on a meter for fun. So I'm gonna be done with the audio demo there. So if you had turned your sound off to not get too annoyed by the drone there, you can turn your sound back on. So let's see, I have somewhere around here, I hope, a cable that will let me, let's try this. I want a cable that'll let me break out my TRS, or TR rather. And, oh, did I leave all those inside? I may have. All right, we'll see if we can just do it with a regular patch cable type of thing. So each of these have it's a TR cable coming off of here, so it's essentially tip ring. So it's positive voltage on the tip and ground on the ring. So I'm going to I have a cable here that's at least it's mono on one side. This should still be on, yeah, even though the laptop's shut, I think it's still getting power. So if I take a look here at my meter, we should have, let's see, there we go. So about 5 volts. 4, 3, 2, 1, 0. So we've got 16 channels of that now. I don't think you're going to go driving motors with those or anything. I'm guessing they're incredibly low current. But if you're able to read analog signals directly on your microcontroller, if you've got a lot of pins and you want to just read straight analog from voltage with this without taking it apart and reading the pots themselves, that's a possibility. And like I said, the other really interesting thing is that we have this I2C coming out of here. So there's not much info online about the I2C protocol that's being used here. It was designed for some of the Monome devices. I think Ansible and Teletype and Crow. There's a few of these synth modules from Monome that talk to each other using I2C. But if you do get info on that, and I think it's all open source, so you should be able to, you could ostensibly write either an Arduino or a CircuitPython library to read that particular I2C, and now you have essentially a 16 fader I2C board, which would be incredible to pair up with something super tiny like a Cutie Pie and be able to control neopixels or something like that. Using all these faders, which I do agree I need to get some fader caps for. I think I might just get the little, just like some small little rubber colored ones that Thunk Synth in the UK sell, and you can buy them anywhere, but shout out to them because they're cool. So that's the basics of this 16N. I just wanted to show it, more of a gear report than anything, but that's one that I was able to resurrect from a broken state and enjoy. And I think even if you buy one new, they might only be a couple of $100 for a kit. I'm not sure about a built one, but they're super cool. So let's see. Toddbot says he uses his laptop like that more than he should admit. Okay, so there's a link in our Discord here to the so Scanner Darkly, who's active in that community, wrote the Teletype wiki entry on this protocol. So I2C in that world is called II, just to confuse me. But yeah, look at the 16N Faderbank source, and you might find some good info on that there. So let's see. Mike Cotterman says he used to pretend I was using the transporter on Star Trek with those faders. It all keeps coming back to Star Trek. So let's see, what else? I think that's it. You know, one you've seen, I don't have it here right now, but I've built a 4 fader using our Stemma QT Neo fader sliders, which are all speaking I2C to one another. So there are options there. In fact, let me show you that guide if you're wondering what I'm talking about. So if you go to Learn and type in fader, how about, not Fander, Neo fader? Maybe it's Neo fader. Neo slider. There it is. Okay, so there's the Neo slider itself, and this one does not have any lighting on it. The one I built, you can see here, I built myself a very similar design, and I put in a set of keys on it. That one has those 4 neopixels underneath, so you can do some fun effects with that. But that was heavily inspired by this 16N, so all credit where it's due. 16N is super cool. And basically a project that came out of the forums over on Lines. Some people said, "Hey, what if we build this?" And they did, and it's still running strong. So that's about it. That's going to wrap it up for today. Thank you everyone for stopping by in the chat. I will be out next Tuesday, as I mentioned, so there will not be a product pick of the week on Tuesday. That'll be back on the 19th, but I will be back here next Thursday for another John Parks workshop, and I should have some 64 by 64 times 2 LCARS RGB matrix madness to show you. So that should be a lot of fun. Thanks everyone for stopping by. I will see you next time for Adafruit Industries. I'm John Park, and this has been John Parks Workshop. Bye-bye. Boo!